All right, and everybody can see my screen?
Yep.
Okay, so this is us. All right, so we are asking the player where they want to move. So just as a, well, here, we'll read this and then go over and look at what we got. So we're going to remove the player from the current room. We're going to add the player to the room they're going to. We're going to display the new room, and your player should be able to effectively walk around the dungeon. Now, one thing, and I've kind of mentioned this analogy before, yes, we're kind of making this dungeon crawler game, but the analogy I make sometimes is like if you needed to give a dog medicine, you hide the medicine in its food, and then they eat it, and now they've taken their medicine, right? So we're hiding, or I'm hiding, object-oriented knowledge inside of this fun for some of you assignment, probably weird for other you assignment. But as we're going to see, we're going to go through here, we're going to be practicing with this idea of self. That's something that you should have had to grapple with for this particular assignment, as well as going through lists of objects and realizing that, oh, this is an object. I now need to ask it for its direction or its destination, things like that. So we're still practicing with those things. All right, so let's go over here and see what we currently have. All right, so right now this effectively builds our map, all this stuff up here. Then we create our player, Mr. Gonzalez, and he is going to get added to room 1, and then we're going to display room 1 for him. Okay. So after we've displayed room 1, I saw that some of you actually had done this, so I'm going to go ahead, we're going to say while true in here. We're going to do something forever. That kind of translates into ask the player over and over and over again. Maybe eventually we have like an exit command that allows us to like type quit or something, and that bails us out. But for right now, we're just going to do something forever. What will we do? We're going to display the current room for the player, which shows them the stuff about the current room and then what the obvious exits are. Then we want to prompt the player. So input, let's see, what direction would you like to go? And we're going to read that in as chosen direction. All right. Now we have the chosen direction, and we are currently in a room. So we need to, let's say I typed in this case, north. So we want to, again, I want us to bring back this idea that we're like kind of on the set of a movie. And these are the different players that are in the world around us. We have players, we have rooms, we have exits. These are the things that inhabit our stage right now, all right? And as a player, I'm standing in the middle of a room, all right? Because I was added to room 1, okay? Now, from this point forward, we don't know about these variables, R1, R2, R5. We do still have access to them here, but very quickly, we're going to be transitioning into our room object. Our room object doesn't know about these variables. It knows about itself. It's a room, and it knows about the exits that it has, which each have destinations to other rooms. All right, so I've chosen a direction. So now what I'm going to do is, and if you remember correctly here, a player knows about the room they're currently in. So a player, they get their current room set by rooms add player method. So when we added Mr. Gonzalez to room 1, we added him to the list of inhabitants for room 1. And then we also let him know that the current room he's in is room 1. If I'm inside of room 1 right now, the variable self is how an object refers to itself from within itself. Okay, so if I pretend for a second that I am room 1, if I'm sitting here inside of my add player method and somebody handed me a player and I drop the player into my list of inhabitants, and then I let the player know the room you are in is me. So I hand him self, I hand him myself for that player to set his current room. So here's player set current room, takes in a room as a parameter, and he sets that local variable called a room, his instance variable, his field. He sets his current room field equal to a room. All right, so a player knows about their current room. So what we're going to do here is we're going to add to room a function called take exit. All right, and this guy is going to take in the direction that we're hoping to go. Now we may end up going nowhere, because if the user doesn't type in something that is, you know, an obvious exit. So for instance, the room we're in right now heads to the north. Well, if I type in east, or I type in hello, something that's not north, I can try to take an exit. I'm just going to bang into a couple of walls before I realize that I'm nowhere in there. Okay, so what do I need to do here? I need to go through this particular room's list of exits, asking each one if its direction is equivalent to the direction I'm trying to take. All right, so we'll say for an exit in self.list of exits. So I'll go through my list of exits, and then I'll ask a question, if. So repetition, asking questions. So if an exit, now an exit here, that guy is an exit objects. Now exit objects have two things they know about. They know about directions and they know about destinations. A direction is a string, a destination is another room. So if this exit dot direction, why is everything highlighted? Oh, whatever. Dot direction, if that guy is equal to a direction, the thing I typed in. So if the direction associated with this particular exit I'm looking at, which is the one of my exits from my list of exits, if that's equal to the direction that I've typed in, then I want to take that exit. I want to go to the room that that exit is currently in. Okay, so room has a list of inhabitants. I could go through there and find my player in that room. Right now, the only inhabitants for a room is the room itself, or is the player itself, since we don't have other inhabitants in here. We'll be getting to that. But we could also have our take exit. Where am I at here? Here we go. Take in the player that wants to take the exit. All right, so I'm going to take two parameters from take exit. And if we go ahead and call that from down there before we write more logic. So take exit requires two parameters and it belongs to room. So down here, I'm going to say the player dot current room dot take exit. So I'm asking the take exit method of the current room that the player is currently in, and that guy takes in two parameters. It's going to take in the player that's trying to take the exit and the chosen direction, which is what the player typed in. okay? And the reason for this is I'm going to search through my list of inhabitants in that room for this player because I need to remove him from that list of inhabitants. Where's take exit? Right here. All right, so if I'm currently looking at the direction associated with the direction I wanted to go, I need to first say self.list of exits dot remove a player. So this will take that player out of the current room, so out of self's list of exits. And then I want to add him to the room associated with this exit. And exit dot add player, sorry, and exit dot destination. Is that what's called destination? Is it destination room or destination? Where's exit? Room destination. So an exit dot room destination dot add player. So this is the room destination associated with this exit. I want to add a player to that guy. What player? A player. The guy that was passed in to take exit. So I searched through and I found the exit that I wanted to take. Once I found it, I removed the player that was passed in from this room. And now I'm adding him to the room associated with the exit we took.
I have a question.
Good.
Should self.list_of_exits.remove be self.list_of_inhabitants.remove?
Probably. Let's see where we at. Yes. List of inhabitants. Thank you. Yep, because we would have gotten not found here for this guy because that player is not in there. All right, so we're removing the player from the list of inhabitants, and so he's no longer in this room. And then we're going to add him to the room that the exit leads to, which will put him into that guy's list of inhabitants. All right, so that's what take exit does. All right, so we'll display the player's room. We'll ask him to give us a direction. We'll try to take that exit. If it finds it, this player, the player we passed in, will get removed from the current room he's in, and will get added to a new room so that the next time through, the player's current room has now changed, and he will be displaying that particular room. So we're in this current room, and I want to go to the north. So now I'm in a dark room. I have an exit to the south as well as an exit to the north. I can go back where I just came from. Now I'm back in that first room. Or I can go to the north. Let's see, what do I have here? I have south and north. We'll go to the north again. Oh, now I have, this is the corner, the center of my cross. So I can go to the west. I can go back to the east. I can go to the east. I can go back to the west. I can go to the north, and now this is our boss room, right? Okay, so go back to the south. Now, if I type in something that wasn't found there, I type LOL, it just keeps me in the current room because LOL is not one of the southwest, northeast exits. Okay, so I think, does that solve the homework? Now, hopefully, once you see this working, it's significantly easier than you thought it was as you were originally doing it. Because what we're doing is we're using these players or the actors in our scene to work together to accomplish a task. The player is in some current room. That room is changing as we go through here. What the player is asking the room he's currently standing in to display itself. Then we're asking the player to choose a direction. We read it in. Then the player is asking their current room to help him take an exit. And he's going to pass himself in because the player knows about his current room, but the current room only knows about the player because he lives somewhere in his list of inhabitants. We could search through that list of inhabitants for the player, or we could just pass it in here so we don't have to search for it, since we have it conveniently available to us, the player we want to remove. Consider moving forward that we're eventually going to get to a place where we're going to have, we might change this variable name. Instead of a player being passed in, it'll be an inhabitant being passed in, where any inhabitant can leave a room, because we might have players that are going in and out of rooms like we have right now, but we might also have monsters that are going to be going in and out of rooms as well. We might have our world feel kind of alive with things kind of wandering around and stuff like that. Okay, so questions about, well, here, let's just finish walking through this real quick. So this player is going to try to take the exit for the room they're currently in. What does take exit do? Take exit's right here. It's going to search through the list of exits for this room, trying to look at each exit's direction to see if it matches the direction that was passed in. As soon as it does, we'll remove the player that was passed in from the current room and add that player to the destination room. And all that is occurring inside of an infinite loop here that just goes on forever. All right, so questions about that, that code? Okay, so let's keep trucking here. Let's give ourselves the ability to dump out of the cave. So maybe we give ourselves kind of a list of instructions that we can respond to. So what we're going to do here is, if we we're going to change up. Actually, let me give you this code as a starting, well, as the solution to the homework before I start modifying it. Okay. Oh, and I mentioned it at the beginning of class, but if any of you are still in the Mequon area and are interested in playing around with some of the VR stuff, since we're all away from campus, we have a bunch of headsets at the school that are not currently being used, so we can lend those out if you want to participate in some, I'm going to call it research, but looking at ways we can use VR as a mode for some human interaction when we're not face to face. You can certainly play games and stuff on it, but that's not the goal of this necessarily. I'm thinking more like, you know, getting together in a shared area to watch a movie or play board games, or you know, there's some things on there where you can like.
Question about that.
Go ahead.
What VR sets would you recommend?
It depends on what you have. So we have a bunch of Oculus Go's, which do not require any extra computer. So they're just standalone. They would be for entertainment. So you can watch movies and stuff, like watch Netflix on a 100-foot screen, that kind of stuff. If you have a fairly powerful gaming computer, we have several Oculus Rifts and a couple of HTC Vives that we can lend out. That would give you something for a more powerful
Oculus
computer.
Rift. Got it.
But most of what we have is Oculus Go's, which would give you more of the social thing. I mean, I'm happy to lend out the Rifts as well if you're in the area, if you want to try to play VR games and stuff. But, you know, there are games for the Oculus Go, but it's, you know, much simpler games, like stuff you would have on your smartphone. that type of thing. But the Oculus Go is great for entertainment. You can do all the social interaction stuff. You can, do VR chat and alt space and things like that, and watch, there's a thing called big screen. You can go to the bases, like going to the movie theater. All that stuff works on the Oculus Go, and that doesn't require anything special. It's an all-in-one. You plug it in, you charge it just like it's a cell phone, you put it on your head, and you're good to go. So if you are in the Mequon area, we can arrange for a pickup or something if you would like to borrow a headset. But that will come with the caveat that you have to participate in some of our test stuff to try to figure out, what works, what doesn't work. We're stuck in a house and we want to still have human interaction. All right. So, and if you have more questions about that, ask after class or send me a private message on Slack. Okay. So let's go ahead and give ourselves the ability to get out of this this loop. So, this guy right now is just going to run forever because true is always, 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 always true. Now we're asking the player for a chosen direction, but as you imagine, as we go through our world, and again, I'm kind of connecting this back to this old school type of game called a MUD. Usually the prompt would be, what would you like to do? Something like that. Not really what direction do you want to go, but what would you like to do? All right. And we would read in a command from the player. Now, right now, the commands that we have are going to be, so I just changed up my variable here, are only going to be directions. All right. So game still works identically to the way it worked just a second ago. But we're going to want to have some additional commands. So we're going to have a interpreter type thing in here where we're going to ask some questions. We want to know what that command was. So maybe at the top level, we're going to say if the command is equivalent to, maybe quit, something like that. If the command is equivalent to quit, then we can maybe say goodbye, something like that, and then we will break out of our loop. And what we could actually do is we can actually put the goodbye outside of our loop, so that whenever we get out of this loop, because there might be some other ways that we get out of this loop other than typing quit. I don't know what those are yet, but there might be. So any way you cut it, when we exit this loop, we'll tell them goodbye. All right, so if they entered in the command quit, we will break out of the loop, which will get us out of this guy, dropping us right here, and we'll print goodbye. Otherwise, we're going to assume that it must be a direction for right now. Okay. So we'll go ahead and run this again. What would you like to do? Well, we can go to the north just like before, taking a direction, or I could type quit and that gets me out of the game. So now my program has ended. All right, so again, we're practicing with what does the break command do? Break gets us out of the most local loop. All right, so this is a loop that goes on forever. Generally, you would say that it's not good programming practice to have infinite loops like this, but this little trick is a good 1-2 punch for doing something forever until a very specific occurrence happens. We could certainly say something like, while the command is not equal to quit, keep doing this stuff, and then break out, but then we have to restructure our stuff in here a little bit, where I think the way we have this right now makes pretty good sense. So we might as well just say, hey, I want to do this forever. I want to, potentially, my game's going to last forever. We're going to be stuck in here. We're just going to keep playing. But if I do have a magical word that will get me out of an infinite loop, and it's called break, and I'll go ahead and use it. Okay, so now we can quit our game or we can take directions. What else might we want to do in our game?
Perhaps search the area?
Okay, so maybe kind of look again for right now, because right now our room, our area is just a list of inhabitants, a list of exits, a title, and a description, right? What you're saying is maybe a little bit broader for a a more fleshed out game where you might there might be some hidden objects in the room, some gold coins or something like that on the ground that we didn't necessarily see.
Or a key.
Stuff like that, yeah. But right now our world doesn't have that, so maybe we want to have if command is equal to look. That means we want to look at the room again, remind us what's in the room. And this is kind of a little bit forward thinking because realistically, I don't have to glance up that far here to see the room, right? But if you imagine in a once we get a little bit farther into this game and we start adding something called multi-threading into it, where we might have monsters coming in and out of the room, this is, you'll get things that appear on the screen that'll say, so-and-so has arrived, something like that. And your information about the room you're in might get pushed up off the screen. So you might want to type look so you can see an update of what's currently in the room or something like that. All right, so actually, let's go ahead and leave that pulled up so we can see it a little bit better and I can scroll this. All right, so if we type in look, that means we want to see the room again, right? So if break gets us out of a loop, what takes us, because notice the very first thing that happens in our loop here is displaying the room. That's what we want to happen when we type in look. So if break gets us out of a loop, what's the command that skips the rest of this iteration through the loop and takes us back to the beginning of the loop?
Continue.
Yep, continue. So continue will say, okay, I'm done with this particular pass through the loop. Why? Well, look means I want to display the room, and that just happens to be the very first thing we do the next pass through the loop. So I'll go ahead and type continue. We'll run this. What would you like to do? I'll go to the north. I'm in here. A bunch of stuff has happened. I'm going to type in look, and it shows me that room again. Okay. So that's our continue command. All right, so now we have a way we can walk through our dungeon. We can look around the room we're in if we've forgotten from 4 lines above us, and we can quit out of our dungeon. Okay, so at this point, we're kind of at the limit of what our dungeon has to offer for us. So now we want to start putting some other things into our dungeon. Maybe we have monsters in our dungeon. All right, particularly we might put one in that boss room. All right, so we want to go back and think about, we're going to update a couple of things here, and then we're going to be starting to talk about inheritance next class. So we're going to have something called a monster that's in our dungeon, because dungeons are filled up with monsters. All right, so a monster might have a name. We'll keep it simple. He's just going to have a name. Now, when we're in a dungeon and we come across a monster, what might we do with it? How might we interact with monsters?
Fight or run away.
Okay, so we can run away from them, which would mean basically exit, right? Take whatever exits. We already have that ability. Or we might fight them, right? Might get into a brawl with the monster. All right, so if we're fighting the monster, at some point we're going to be attacking, right? Okay, and so we're going to be doing some damage to the monster. The monster might be doing some damage to us. So we're going to have some way of keeping track of how healthy we currently are. All right, so a monster might have a number of hit points. Sometimes this is just called HP. All right, so a monster is going to have a number of hit points. Whenever we hit the monster and do some damage to it, those hit points reduce. And whenever he hits us, well, right now we're kind of immortal, so we can't take damage because we don't have hit points. But we're going to have to add to our player the ability to have some hit points. Okay, so we're going to go ahead and let's build a monster object, and let's adjust our player object. So we'll adjust our player object here first. It'll only take a second. Okay, so a player is now going to have a self.hp for hit points. Actually, let's spell it out. Hit points. HP is going to be a very familiar term to many of you, but if you've never, if you're not a gamer or something like that, you're what the heck is HP? So we'll hit points. This is your amount of life you have. All right, and let's just say that a player starts off at 10 life. Okay, we'll just hard code these numbers. Eventually, we'll randomize some stuff. But a player is going to have 10 life when they first come into existence. All right, and then we're going to go ahead and create a class for a monster. So class monster. Now, just giving you a little foreshadowing here, since monsters have names and hit points, and players have names and hit points, it might make some sense soon for us to have kind of a top level class that represents a inhabitant. We've already started using that term. And all inhabitants have names and hit points, but then they differentiate themselves between players, which are human controlled, and then monsters, which are computer controlled. And maybe they do a little bit different stuff, whatever. But when we start talking about inheritance in the object-oriented model, we'll update our thing for that. But right now, we're going to have a little bit of redundancy in that we're adding hit points to player, and monsters are also going to have names and hit points. So we've kind of written the same thing twice for two different things that are almost identical to each other right now. All right, so a monster is going to have a constructor. It's going to take in a name. And we'll go ahead and also take in a number of hit points initially for a monster, because we might build in monsters that have some additional different kinds of strength associated with them. So, you know, in our boss room, we're going to have a fairly strong monster, yet in some of our other rooms, we might have little rats running around or something, and they're pretty weak. You know, so maybe you can kind of kill a rat with a single swipe, something like that. So we want to have the ability to add a little for us to describe the strength of the monsters. All right, so we'll say self.name is equal to name, self.hit points is equal to hit points. Okay, now, and we can go ahead in our room right now has something called add player. Now we also want to go ahead and give it something called add monster, let's say, because players and monsters are a little different from each other in that a player always knows what rooms they're currently in, because we use that. Now, that might be something that's helpful for a monster to know, but for right now, we're going to purposely differentiate monsters from players. And a monster doesn't necessarily know where in the world they are. You know, they don't have to know what room they're in. All they have to know is that they are standing there, and they're going to have the ability to fight somebody. Okay. Eventually, when we start having monsters move around the world, they're going to have to know what room they're in. but we're going to purposely not put that in there so we can kind of create the feel that we're differentiating players and monsters from each other. So inside of room here, we're going to say add monster. All right, this guy will take a monster as a parameter. And what we'll do is we will add that monster to our list of inhabitants. Self.list of inhabitants dot append a monster. Let me quit out of our running program here so it stops kicking me down there. All right, so we will add a monster to our list of inhabitants. Now that monster will be in that room. And then what we're going to go ahead and do is we're going to create our boss. And remember, our boss is in room 6, right? So we're going to go ahead and create the dragon. And it's going to be a monster named the dragon. And he's pretty powerful. So we're going to have him with 15 hit points, stronger than a human. All right, so it's going to be we have to get lucky to get through the dragon. All right, so we have the dragon. And remember, monsters, they take in a name and they take in a number of hit points. That's what the init function for monster takes in, a name and a number of hit points. All right, so that's why we built it that way. So now we just have this dragon standing here. We ultimately want to put him in room 6. You know, so we're kind of laying out our world in front of us. So we'll say R6 dot add monster the dragon. All right, so now he's standing there in room 6. So if we go ahead and hit play here, and we run up to room 6, so that was all the way to the north. Oh, we were building up our inhabitants string for the get full name. Because remember our player, well, actually this is a good error to have. For a monster to display itself, I'm sorry, a room to display itself, we go through our list of inhabitants and we get that inhabitant's full name. We ask it about its full name. Well, monsters don't have a get full name, right? Monsters only have a name. Whereas we wrote the get full name thing in here because a player, we used our old player, which had a first name and a last name and an age, all these things, a jersey number, but these things are really unimportant in our fantasy dungeon here. So why don't we update player to only have a name? He doesn't need an age or a jersey number. We could always add age back in later, but we're not using it now. All right, so we'll set this player's name equal to the name that was passed in. We won't keep track of a last name or an age. We won't keep track of a jersey number. We won't keep track of a full name because we already have his full name inside of name. So we no longer need a function called get full name. And when we display a player, we just have to display self.name. We no longer need that pretty print string that puts their name all together. All the other stuff there is still the same. So we've really simplified player. So then down here or up here in room, when a room displays itself and we get an inhabitant, we no longer ask that inhabitant for its full name because it doesn't have that function anymore. And monsters never had that function. So we'll just get the name from that inhabitant. Every inhabitant, both right now our inhabitants are players and it's monsters. So every single inhabitant has a name. So we're going to go through our list of inhabitants and build up a string that has every one of our inhabitants' names in it. Okay? So then we need to go back down here when we're creating our player. And now we only pass in a name for our player. All right, because we've modified players to now, just as a reminder, if I scroll up and show you player, a player now only requires me to pass in a name. We didn't require all the age and jersey number stuff anymore. All right, so we'll run up to the north. All right, and we see also here, we see the dragon, and we see ourselves here, Mr. Gonzalez, which maybe is a little bit weird when it says also here, but that's fine. We're showing the entire list of inhabitants instead of everybody except us. So we have the dragon sitting in here. Okay, so now let's go ahead, and before we go and fight the dragon, which might be a losing battle, we'll go ahead and we will create a much weaker opponent in our first room. So we'll call this guy the Rat. And this is going to be a monster called the Rat. And let's give him 3 hit points. All right, and we'll say R1.add monster the Rat. All right, so now we see right here in the cave entrance, we have a rat standing there ready for us to attack. All right, so now we want to think about what does attacking mean? And this is what our homework is going to revolve around. Allow a player to attack a monster. A fight to the death then breaks out, where the player, since the player will attack the monster instead of the monster attacking us, later on we might have some monsters that are hostile to players, where as soon as you enter the room, the monster attacks you and gets the first swing. But for right now, we'll have our player always initiates the attack. So a fight to the death breaks out where the player attacks first, and then the fight goes back and forth until someone dies. For right now, a fight let's see, for right now, let's say there is always a 50% chance of hitting the opponent. And if you hit, you always do 1 damage. After each attempted swing, display some info about whether there was a hit or not and what the current status of both combatants is. So as an example, you might say, kill rat. That might be your initiating sequence. And then from that point, you might get you hit a rat for 1 damage. And then it'll show the rat, 2 HP, something like that. And in our case, Mr. Gonzalez, 10 HP. Then the rat misses you maybe. And then it'll show that same output because the rat only had a 50% chance of hitting you and just happened to miss. Then maybe you miss the rat. Show that same thing. The rat hits you for 1 damage. Now you're at 9 hit points, so on and so forth. Goes back and forth like that until somebody dies. All right, so that's what we're going to add to our game for Wednesday. The ability to have a kill command now, where whatever you're attacking, you'll attack it by name, so it'll be the rat. You go into a sequence where you have a 50% chance of hitting each other until one of you dies. Questions about what I'm asking you to do? And I'll give you this current code as a starting point. And I will see everybody on Wednesday.